All right, maybe we can get started. Hi everyone, my name's Mike. So I'm the CTO for a company called Pragma. And what we do is continuous delivery and DevOps consulting and coaching and training and so on. I do a lot of courses around Docker and so on. But before I joined Pragma, I'd spent almost a decade working with embedded systems. And that's what I want to try and do, is marry those two worlds together into some kind of demo and talk for you today about how to create binary reproducible builds using native build tools and Docker. So if you were on my course on Tuesday, I think, then probably you might want to find another talk because you'll have seen most of this already. But otherwise, you're welcome. Just a fair warning, there's a lot of good talks tonight. Yeah, so don't waste your time. So originally this was called binary reproducible builds with Docker, but actually I felt I had to drop that with Docker bit. We are going to use Docker, but actually you don't need Docker to do binary reproducible builds. It's easier, but it's not only Docker that you need. It's not only the environment you have to care about. There's a lot of other things you have to be concerned with, so that's why I've just kind of turning this into a binary reproducible builds talk. So I'm going to talk about what they are, why we would care about them, talk about build environments, how to make predefined build environments, how to have deterministic builds with deterministic inputs and deterministic environments, the validation systems, and then we'll do a demo from the very beginning how to make a reproducible build with a very simple project. Does anyone here have to do binary reproducible builds for their current projects? No, okay, cool. So binary reproducible builds. There's kind of two main classes for why you would need binary reproducible builds. The first case is if you're doing usually some kind of embedded system that is operating in a regulated market, like aerospace, like medical, like automotive, these kind of areas. So normally people think about embedded software, if they're not from the world of embedded software, they think about washing machines and tumble dryers and boring stuff like that, but actually it's usually a lot more complicated, the types of embedded software we make. Often it's stuff that's working in medical, so it's safety critical, and people die if the software doesn't work, and they have died in the past, so it's very, very important that it works correctly. Automotive and autonomous vehicles, autonomous robots. Again, there's a lot of lives at stake if these things go wrong. Maybe less obvious kinds of robots as well, like marine seismic acquisition systems. Now, I don't think that there's such a necessity for binary reproducible software there, but you never know. And then, of course, the things that go bang. So not every kind of software, not every kind of embedded software requires binary reproducible builds, but those that do, it's really useful. For instance, there's a lot of regulations, regulations you have to follow if you're making medical devices, software for medical devices, and usually there's a very strong requirement for an audit trail to be in place, to be able to prove that the software that's running in a device is actually the software that was coming from a specific version of the source code, which has been gone through all the tests and the qualifications necessary for medical software. So you need to have that kind of red trace all through your system. Now, embedded software is not the only place that it's important or interesting to have binary reproducible builds. Oh, one more thing before we get to that. So the other thing is that embedded software is a bit special in that it tends to hang around forever. It's usually in a safety critical environment. Often in regulated markets, you don't get access to production for legal reasons, and not just because the IT department doesn't like you. The tool chains are often custom, so you have a very, very specific set of tools that you're supposed to use, and you have these audit trail requirements. And in that world, actually, configuration management is still a thing. Now, there was a point in my career where I was also what was called a baseline manager. So it was my job to be the build machine. where I'd get all the different components and make sure all the software compiled. Has anyone ever been a baseline manager or configuration manager, anything like this? It's not a fun job. I promise you it's not a fun job, and that's why we have CI servers now. But the thing is, configuration management is still a thing. The fact that you still need to know all the versions of all the components and the tools and the source code is still a thing in a lot of environments. But there's other places where it's interesting too. For instance, we have a lot of software that we rely on for security. It's like at the very basis of our security. SSH is a good example of that. We wouldn't like it. We take it for granted. I take it for granted when I type SSH at the command prompt that it's a good version of SSH. If I run an SSH daemon, I'm trusting whoever made that has provided me a good binary. Other kind of security vectors or common vectors for security attacks would be getting in a rootkit into the kernel or into our hypervisor. These are also places where we'd really like to make sure that nobody's put in backdoors that we don't know about. And yes, security software in general. Now, the Debian project's done an awful lot of work in this space around binary reproducible builds. There's reproduciblebuilds.org that they've been doing, and they've been going through many, many packages, step by step, making them binary reproducible, and they've been doing this for years. It's specifically for this reason, so that we can have trust in the binaries that we're using. So, Jeff Atwood made this blog post about 14 years ago, and he says, if the build process is the F5 key, you have a problem. Get your build process out of the IDE and into a build script. And that's good. Obviously that's good, because then we can all build in the same way. So you can build the same software in the same way that I build it. That's great, but in the end, we're still kind of doing that in a lot of open source, especially, where package maintainers are performing builds, maybe on build machines or so on, but it's not really, you can't really prove anything about the environment in which it came from. So yes, having the source code and a build script is quite helpful and necessary for reproducible builds, but it's nowhere near sufficient. So reproduciblebuilds.org, they have this kind of what is reproducible builds, and they're a set of software development practices, so a bunch of practices, not just a process or a tool, to create an independently verifiable path from source code to binary code. So what they're thinking is that actually the build process should be like a one-way hashing function. You have your source code and whatever it is, you have your build process, which is your hashing function, should always produce the same output. So imagine you're starting with your version of OpenSSH, for instance. You clone the Git repo, you perform the build, which is probably some kind of make process, and then you get an app. And what you want to do is to make sure that every time you perform a build, no matter what, you get the same result. Why does this matter? Well, most software is distributed in binary form. Not many people build their operating systems from source. So if that's true, and there is no reproducibility, which is true for the majority of software in the world, you have to implicitly trust the distributors. You have to trust what they're giving you. This makes attacks on developers and build infrastructure very attractive, because that's the weakest part of the whole system. If you wanted to put a backdoor in Linux or in OpenSSH, the place to target would be the build environments, because it's completely undetectable. If someone puts in illicit changes during the build process, if you don't have reproducible builds, there's no way to know. Make sense? Cool. So now that you're all completely convinced that reproducible builds are super important, how do we get them? So you need to have predefined build environments, deterministic build processes, systems, and inputs, and some kind of validation system, some way to check, which actually is really easy. So we'll go through all of this. I'm going to run through these things, look at different aspects of this, and then we'll get into a bit of a demo. We'll take it from beginning to end. So predefined environments. What makes up a build environment? this is a question for you guys. What kind of things would you have included in your build environment?
Compiler.
A compiler? What else?
A linker.
A linker. A preprocessor. What else?
Artifacts.
What kind of artifacts?
If you have something graphical, then it would be a picture maybe.
Ah, like the binaries and so on that go in as inputs as well, yep. Anything else?
Your build tool.
Your build tool, excellent. What else? Source code, very important.
Or your libraries.
Oh, your libraries? There's a bunch of things, right? The compiler, the libraries, the build tools. Things that you don't often think about are your environment variables. That's part of your build process. It's part of your build system. Your disk. What's going on in your user local include? That can have an effect on your build output. And of course, yeah, the code is also part of the build process. So normally when people think about the build environment, they think about the like GCC and then the libraries and then the build system, but it's actually a lot more. And this is just like some of the things you could care about. So one thing you can do to try and calm down and tame the environment, or at least make it a bit more reproducible, is well put all those things like the libraries and the tools in a place, like on a shared disk, on a file server, in an artifact management system like Nexus or Artifactory. That's a good start, so we can all start to share the same tools, whatever that means. But you can go a step further and put all those tools in the environment into a Docker image so that everybody can share the same environment. You don't have to also install all the tools and also set your library paths and also so on and so forth. So we'll go through an example of that. The reason why Docker is quite interesting in this world is that Docker, at its essence, is a dependency management solution. What it does is give you a standard way to pack up an application or a process together with all of its dependencies in kind of a standard unit that you can share around. It gives you some isolation so you can have them side by side. So we could have GCC 5, 6, 7, 8 all next to each other in Docker containers without ever wondering if we happen to have gotten the paths wrong. And it's portable, so we can share it with other developers really easily. The other thing that's nice about Docker is that you can create the Docker images from code, or at least a Docker file, which is not exactly code, it's more like a recipe. But anyway, you can have some kind of verifiable way of creating the image. So this is a Docker file, it's just an instruction. This will say, I want my base image to be Ubuntu 14.04. Run apt-get update and install curl and vim for me. Actually, this is bad because it won't work. Let me just quickly fix this for you guys.
-Y.
Yeah. But I can't get in here. Ah, I know. There we go. Can't have broken code in my slides. That would not do. Right, now I've given away the next step, is that none of this is reproducible, right? Because if you have this, if you build a Docker image and I build a Docker image, I have no idea that you're going to get the same version of curl as I do. Or if we build this in 3 weeks' time, will that be the same version of curl? Will even the Ubuntu that we base it on be the same? Probably not. So this is a way to make an image, but the image itself has to be the build environment, not the Docker file. It's really important. And then we can share them. You could use like open source, you can use public image repositories like Docker Hub to store your Docker images. You can host them internally in your own repositories, however you want, but it's a way that you can store these and share them amongst the developers. And that way, when we have a build process, we can build with Docker here on our local environment, and we can use the same image to build on our CI system and use the same build environment everywhere and for all developers, so we can be guaranteed at least that we'll always have the same environment. Okay, so now we've got the environment under control. We're still not quite there yet. There's a few other things that we have to consider. It's actually quite a lot of things we have to consider. So the first thing is we want to make sure our inputs to the build process are stable. We can't have volatile inputs because as soon as you do, you no longer have reproducible builds. So here's an example of a header file that's generated by a Gradle plugin. And it's all about tracking versioning information so you can stamp it inside your binaries. Very, very nice thing to do. Very, very important for traceability and audit. But you'll see here, it's got timestamps in it. So if you do the build twice, you're going to get a different result. Which isn't great. Compile time timestamps are problematic. So if you use underscore underscore time underscore underscore or underscore underscore date underscore underscore, any of these macros that will provide you something like this, they're problematic. Now with GCC, you can set it to create a warning if those macros are used. So that's a good way to make sure that that doesn't sneak into your code in the future. Other kinds of inputs that can pop up, sneaking in build numbers from your build system. The next time you build, even if it's exactly the same shot, this is going to produce build number 178. And then again, your build's going to be non-deterministic. Now, file paths are interesting as well, because in general, if you were to build, say this was in an application and you were to build it twice, it would provide deterministic output, assuming that there was nothing else volatile on its inputs. However, if you were to build this same project in a different file path, then what would happen? It would have a different file. So this would be a volatile input. So if we'd either all have to agree, every single person in the world who was going to compile this would use the same working directory, like /temp/build, that's what everyone's going to use, or we might want to find a different way. You can use a fixed path. You can also use Docker for this. I'm going to show you how we can solve this problem with Docker. Some people thought we could maybe get around this if we just strip the binaries, because it's going to be in the debug symbols. So, okay, assuming you don't have this macro, you still have this problem because the debug symbols have got the path in them. Now, if you strip the binaries, you still have the problem because there's this thing called nt_gnu build ID, which is used by the debugger. I think it's used by GDB. But it's a little unique build number that's like stamped into the object files, and it's unique to each path. So even if you strip the binaries, that's not enough. You still have to build in exactly the same file path. Yes?
You can do, when you build it, following GCC, you can use -d, and you can like file_name, and you can put in the name, and then instead of using the file macro, and we'll just get the, you can sort of use the, when you call GCC, you can give it as an argument that only the file name without the path.
Absolutely. Like, so you don't, I mean, if you don't give the full path, you can control it in lots of different ways. Yes, absolutely. Another thing that I never really thought about, this was an example from Coreboot project. They had some uninitialized data in the stack, and that would just be random, what was in there. So you would build it 2 different times in 2 different places, and the binary would have a word that was different. Yeah. So very simple fix. I mean, probably shouldn't have uninitialized data anyway. It's going to cause a stack leak, but it's fine. And then the compiler itself is working against you. So the compiler, for some aspects of GCC, it's going to generate random symbols. And it just uses a random number for each compile. I guess it gets a GUID or something. I haven't looked at exactly how it does. And this is used for, well, it says here coverage data, but I know it's used for name mangling as well. So what you can do is you can, for each file, put in a random seed for that compilation, for that translation unit. Now, the trick is that this has to be different for every file you compile. So how do you do that? Well, there was a very clever guy called Jörg, who I've never met. Seems like a nice guy though, because he came up with a really good solution. In your makefile, what you do is you shell out and take an MD5 sum of your source file, take that sum and use that as the random seed. So that's kind of a stable way to solve that problem.
But do not have two identical files.
Well,
You don't have the path and
that's true. If you had two files that resulted in the same MD5 sum, I think you would be very unlucky.
yeah, but I'm thinking of two actually files with the same content.
Right. Yes, but then they would produce two object files with the same content, which would probably provide clashing symbols. You couldn't link them together anyway, I guess. Yeah. I'm sure there's probably a way, though. You're right. There's probably a way. And then the linker is also working against us. But modern versions of AR have this this capital D flag, which says, please be deterministic. So like zero out all the things that have got timestamps, UIDs, GUIDs, and use consistent file modes everywhere. And that way you'll get the same linker result every time. Now, some of you might be working with old versions of AR that doesn't have this -D, or this capital D flag, and then somebody has created an AR timestamp wiper, which is like a little utility that will go through your archives and like scrub them up, if you like. Right, so that was just kind of a quick tour of the different things that you can get tripped up on. But there's more. There's much more, actually.
just a question.
Yep.
If you wipe timestamps from your AR or binary output, do you do that? You do that only for creating the checksums, right? Or do you actually?
You could ship them. There's no reason not to. That's the kind of the whole point, because what you want to do generally is to say that the thing that you've shipped is reproducible.
But if you have a mechanism to check that, you know, if I strip this the same way every time, you know, I remove this and then I derive at the same checksum.
You could do that too, for sure. I mean, you could say, well, we're going to ship it with all this non-deterministic stuff, but we know that if we strip these, run this script to clean up the binaries, and we get the same result. That's true. Which brings us nicely onto how do we check for all this stuff? So it's pretty simple, really. If OpenSSH produce a binary, well, you just clone the repo, do the build process, and check if they match or not. If they have the same MD5 sum, then we're golden. Otherwise, there's probably some shenanigans going on. Someone's not telling the truth. Yeah, and of course, you can automate that process as well. And this is what I think the Debian Reproducible Builds project's doing. They're trying to rebuild the same binaries in lots of different locations, because location actually matters for results as well. Locale can make a big difference on the output of your build process. I didn't know this, but when you do a glob in shell, the order is not guaranteed. So you can get different orders on different locales. If you create an archive or a tarball, that can have also non-deterministic orders. So there's lots of ways that non-determinism can sneak into a build process. So yeah, let's do a demo. Right, so I have an open source project called fff.h. It's the fake function framework. And it's a header file only framework for faking C functions so that you can write unit tests. It's a bit of a, you're not supposed to read this file. So this was not handcrafted, I promise you. It's generated by a script. But it's good enough for our uses, because what I'm going to do is I want to make a binary reproducible release of the test suite for this framework. So I've got two test suites. I've got the the FFF test CPP, which is testing the framework in the context of a C++ program, and also one that's testing global fakes as well. So I have all the test cases in here. So there they are, looking pretty. And we'll have a makefile, which just, the tests are using Google Test, so I've got Google Test included here. So it builds Google Test, and then it builds my test suite. And what I want to try and do is to make those, the binary that I produce from my test suite to always be the same. So, first things first, I'm going to start with a Docker image. I want to have a Docker image. I'm going to base it on Debian latest. Now that's already a mistake, isn't it? I should probably fix that. So let's go to, can anyone tell me why that's a mistake? Yeah, it keeps changing. So let's have a wee look over here. I mean, anyway, it's going to change because tags are kind of more like branches. So if you get, so let me see now, where is latest here? Anyone see latest? There it is. So I'll take this one, which is actually the same. Hello. Stretch to 2018. Stretch 2018. 0716. 0716. So this is July 16th, 2018 build from Debian. Do an apt-get update, which of course is non-deterministic, and I'm going to install a build system. I've got proc CPS in here. I don't know if I need that. Anyway, it's fine. And I'm going to set the working dir to /code, because I want the working directory to be the same every time. We'll see why that's important in a second. So I'm going to build this. So Docker image build. I'm going to call this Microsoft, what's this? FFF. What version is this? 1.1 sounds good, doesn't it? Let's build that. So it's going to build me a version of like a Docker image based on Debian, the version of Debian I mentioned, with the build tools and a working directory set. Now I can run this. I can, for instance, run bash inside there just so we can have a poke around. Like this. There we are. We can see that the present working directory is code. There's nothing in it. And if I look at /, now this is a container. So this is not the image. This is a container based off of the image. So I can do whatever I want here. And the next time I create a container, it's going to be fresh and clean again. So you really are protecting yourself from side effects. So I can, for instance, remove the /bin directory. And now I won't be able to do that. Oh no, that's a built-in. I won't be able to do that. I probably won't be able to, oh no, I can do that. What else have I deleted? Ah. Yeah. Anyway, can't do a lot of things without /bin. But I can exit that, create a new container, and everything's back again. So it's a good way to make sure that you can always have a fresh environment for your build process. Cool. So now I have that. I want to get my code inside there. So here's my code. This is what it looks like. Now I can do the same container run, but this time I'm also going to have a parameter to mount a volume inside there. So I'm going to say pretty please with sugar on top, could you take the present working directory and mount that inside /code in the container? So now I'm going to be able to access the present working directory from inside the container. Cool. And now I should have my code in here, which is great. Maybe I'll just raise this up a bit because I can see at the back it's not very comfortable to read. Is that okay? Yeah. Oh. Great. So there we are. Now I've got my code in here. I should also have GCC. Yep, I've got a GCC. Yeah, let's have a go. Make all. Please work. There it goes. Off it goes and builds. Now I've changed the build process to also, once it's created something, give me the MD5 sum of the archive. So we can see that the MD5 sum of this build starts 60C3. Cool. Now if I do make clean and then make it again, I should see the same MD5 sum if things are going well. And I do. There it is there. Right. Now then, if I was to copy minus R code to code 2 and make clean, I guess, and make all, I guess it's going to be a bit different. And it is. The MD5 sum is now F9DE. Okay, so obviously we want to be in that /code directory if we want to have these deterministic builds. I think, do I have strip here? I do. Strip, what's it, bin / no. That's true. So let me strip the symbols from it and then do an MD5 sum of this. There we are. So 672. And then if I do strip of bit in this directory, and then the MD5 sum, it's still different. So there's still stuff in there that's non-deterministic if we change the directory. Great. So now I've got a deterministic build environment. I can build in code over and over again and get the same result. I'm quite happy. So I put this code up on GitHub and I can make a release and put the binary up there. How does anyone verify that this is a genuine FFF test suite? Now this is the important question we're all begging to find the answer to. So what we can do is we can push this Docker image up to Docker Hub. So Microsoft /FFF. I don't know if I'm logged in. I hope I am. Looks like it. Very good. So there it is, up there. Now, I could, for instance, connect to a virtual machine I created on Amazon or wherever. I'm sure if you have your laptop, you can join in. I can do a git clone of whatever this is. Cool. Nope. So I'll clone that repository locally here and have a look. CD repro. Do you remember what the MD5 sum was? It was something like that. But do you know what? We can reproduce it. So instead of running bash, I'm just going to short circuit this and say make clean and then make all. There it goes, toddling off.
Did you do the clean?
Sorry?
Wasn't the clean in a different container?
Yeah, but I'm mounting that directory in.
Ah, yeah.
So it's persistent in that sense. So it was 60C, which I think is what you said, wasn't it? Well done. Buy that man a beer. Okay, so I've got my code here. Now I'm going to check this Microsoft, see if he's got a reproducible build. So I'll pull his Docker image. And I'll do a Docker container run -v $. Oh, thank you. Teamwork makes the dream work. /code, and then I'm going to do make clean just to be sure, so there's no funny business. Yeah, I probably need to tell it what image to base the container on. There we go, it's nice and clean. $60C. Cool, huh? Now, we could go a bit further. Oh, we could go a lot further, actually. But let's not get too ambitious. Right now, we're still trusting that this image is something that is kind of sound as well. That's fine. We have to trust something at the end of the day. But we could go a bit further, and we could say, instead of saying where is it now? There it is. Instead of saying that this is just something pushed up that was built at random, we can set up an automated build in Docker Hub so that we can have a clear link between the Git SHA and the Git repo to the Docker image. So create an automated build. Then I'm going to use this repo. Why not? There we go. Then typing is hard. Great, so now what's going to happen is that Docker is going to take care of the build process. So Docker is going to say, for this build, it's going to build, we probably want to call that something else, don't we? Well, we'll take 1.2 for now. There we go, off it goes and builds, I hope. This is a free service from Docker Hub, so we have to be patient with it. But we can see at least that as soon as the build is complete, we'll have the Docker file that was coming from that Git SHA. Then I can use that as my build environment for producing my binaries, and so can everyone else. And it will tie up the trust a little bit more. Right. So that was what I had planned for you today. I hope that was what you were expecting. So we talked a bit about binary reproducible builds, why they're interesting. Looked at how to make these predefined build environments with Docker, how to make sure your code and your environment is deterministic, and how to check it. Thanks a lot. We have time for a couple of questions, if that's interesting. Yeah.
Are there any ways to write the Docker file in such a way that that could be the trust point if you pin down the versions and you say you trust in the case of Debian, you trust the apt repositories,
Yeah.
then you wouldn't have to store and version control this 200 megabyte image.
Yeah, I mean, you could do that. In the end, you're going to have to store what your environment is somewhere, and it's just a question of how deterministic you want. Like, I know a lot of people that are working in the security field. They would never base their images off of random things on the internet. They'd have a random. They would have a hardened base image that, like, you zip in a root file system to begin with, that has the root file system that's kind of been thoroughly vetted by everybody, and that's where you would base it on. And anything you add would only be added from your own package managers. Yes.
Can you assign an image? So
Yes, you can.
So you can check the image signature.
Yes, you can. Every image has a SHA of its contents, and you can sign it with. You can even use a two-factor auth, like a YubiKey or something. So you can go quite far down that path as well. You had a question? No.
About the Docker versions, a new version of Docker, is the possibly.
So could a Docker
image
version
the
change?
same image another way?
No, that's the nice thing. So the image format's quite stable. Docker is not. Like, there's a lot of change happening in the Docker ecosystem all the time. But the Docker image format's very stable, and it's designed specifically that way, so that from an image you get a known runtime every time. Yeah. So it's no guarantee that in 10 or 15 years that's going to be still the case. But as long as you can run Docker images, that environment should be quite stable.
You could possibly inject something like the SHA of the Docker image into the build output and sort of tie it up.
Like to bind them together? Yeah.
Docker containing downloading the correct version of Docker and then run the application inside that Docker again.
Like I said, you can go far with it. You can go far with this stuff. Okay. Thanks, everyone.